So I think by now we have worked with pretty advanced stuff in Python. Like uh, we have worked with NumPy arrays and pandas, which allow us to really manipulate the data in whichever form we like. Right. So what is left for us to learn is I think we've already seen this once how to parse web data, but today we will again see and try some examples so that we are very comfortable. I think after this there will be just one small thing left, which will be Selenium, right? So Selenium allows you to totally automate everything, and then I think that will be good to go. We'll be able to do any kind of scripting. So I think the files that I've shared today, these two files, I hope these two are there with you because we'll be just inspecting these. Almost all the, if I just want to say before starting. So we have these two files. One of them is pricing.html, right? So it looks like one of those page sources. And then there is one more dashboard.html, right? It also has a similar structure. So what we will do is that if I just wanted to see how they actually look like, let me just show you. Right? So one of these pages is like this, right? And it has only this data for now. And the other one is, if I just had to show you, just so let's say you had something like these, right? And you wanted to scrape some data out of this, right? So any page online is actually this one only, right? If I want to see the source, so this is exactly that I have. So whenever I will request something on the web, ultimately in the end I will have something like that. It can be the source or it can be the DOM. I think that we have already discussed earlier. Let me yeah, so it is recording. Anyway, so I think yeah. So we will just try to get extract some of the elements which are of our use from here, and accordingly we will also learn that how to do it for other pages. So if we can just learn it from here, then I think we'll be able to do any kind of web page parsing, right? So again, today also I will prefer using the Google Colab tool, right? Because again, it has almost all the libraries that I would want to use. But let's say, let me allow. But let's say that's fine that you like Google Colab and everything, and it has a lot of functionalities to give you. But let's say you had to uh, run your own Jupyter notebook, right? So if you already installed Python, for which the instructions I have already shared earlier, you will have something like Jupyter, right? This Jupyter notebook, which comes with the Anaconda distribution. So what you would be able to do is open it, right? And then it would kind of open a command line screen, and then it would run that Jupyter network, right? It would run that Jupyter network. Just starts. Let it start. Again, it's taking a lot of time, but you know, let it start anyway. So all I'm saying is that you could use your own this Jupyter notebooks, because now here you can see that something open, right? So here this particular link is what it says, right? That you can actually go to this link, and then if I just go to this link, right, it would open that again this page. And what it says is that now you can do whatever you want here. You can create your own ones, or if you already have some old ones, then you can definitely go there and do. So if I had to just create a new one, I'll just say Python here. I'll press new and say Python 3 notebook, and then I will have a very similar screen uh, to what I have at Google Colab like this. So let's just see how it looks like first. So yeah, I mean, this is the original Jupyter notebooks, and this is Google Colab as an implementation on top of that, right? So it works it again very simple way, right? You can say print ABC and then it will print it, right? So works very similar. But I mean, yeah, that's it. That's what I wanted to tell you guys. One more thing is that here you can see that there is some token given to me, right? Here, the token. Let me just copy it. What I could do is, let's say I wanted to not use Google server, right? Here we have Google server hosted runtime. I could connect it to my local runtime. And then all I will have to do is that give it this backend URL, right? This one. And let me just try it once. I can just give it here, connect, and then reconnect. And its entirety. Right. HTTP over web traffic. So basically, there is some issue coming, but you can obviously search this online and see how you can connect it. All you'll have to do is put this link here, and you can connect your own hosted runtime. But for now, we will use Google's runtime. So let us proceed. I think this should be useful for someone who would want to use their own Jupyter notebooks rather than using Google Colab, because you might have some system which is even better than the Google Colab one, right? So anyway, I'll just close it. I'll just close the Colab notebook and close the Jupyter notebook and go to the Colab notebook. Okay, right. So first thing, so today we want to look at BeautifulSoup, right? It is a very, I mean, very popular module. Uh, is popular since a lot of years. It is one of the most popular module to do HTML parsing, allows use of selectors, XPath, names, text to extract tags. So basically, whenever we are getting data, ultimately, the web data is actually this source, right? This is the data that we will get ever from the server, right? And then we will have to extract these useful components from it. Okay, that will always be the case. So we have already seen selectors in one of those lectures where we were looking at JavaScript. We'll see it again, but basically it allows you to choose use selectors, XPath names, right? Names of the elements, text inside those elements to extract those texts, right? So very beneficial. It also allows for manipulating tags within documentary, right? So basically, when the DOM is created, there is a documentary, right? This is exactly what a documentary is called. So you have a tag nested under the nav tag, right? And a div tag nested under a body tag, right? So you can imagine it as a tree where something is nested under something else, and there are some levels. Okay, anyway, but your task is that how you would traverse through that tree to get the element that you want. Okay, so I'll just close these. So let's go back. Let's see. Right, before even starting to use BeautifulSoup, I hope everyone understands from these three things that what it exactly used for. It basically allows you to manipulate tags and uh, extract your data that you want from it. Okay, so I mean that is it about it. I think let's do some practical examples to see how exactly it works, and then it would make more sense that what exactly it allows you, right? Here. So anyway, let's. So I'll just load my HTML file, right? Generally, when I will make a request to server, right? What I would do is that I would do request.get, and I would, let's say, ask for this link, right? And this link would return me a response, right? And that response will be this, right? But what I'm doing for purpose of our example is that I have provided you with two files, which I've already uploaded here, and then I'm gonna read it because I don't want to make a request. These are just small examples. So after this, I will make a request from a server and then get the data. But before that, let's try exploring this. So I will just do, let's say, dash data, and I will say open, right? This is how we open a file, and we will say dashboard.html, right? And we want to read the file, right? So we will just give it a mode of read, right? This is fine. So now my dash data holds an object, which is like, let's say dash file, right? Because currently it just holds a file. It does not do anything. It does not hold the data. So what I can do to read the data, I can say dash data, right? I could just say dash file dot read, right? So we've already seen this, right? And if I, just print my dash data, right? What I will have, I will have is that I will have something, right? I will have something, okay? And this something is exactly what was there in this file. But if I just check the type once, right? I will check that the type is a string, right? But that is a big problem for us because with strings, what we can do until now, what we have seen is that we can traverse a string. We can probably find something from that string. We can slice it and do some of the operations. But even when we have all of those functionalities with us, right, then uh, we would not be able to traverse a big file like that. I mean, we just saw how big that string was, right? So using just it as just a string, I don't think it could be. I mean, you would also be able to apprehend that it would be difficult for someone to parse that. Just a second. Yeah. Okay. So we will have to convert it into some other type. Any issues, anyone? Okay, no. So now we can see that when we read it, right, by default it was a string, but with such a long string, I don't think we'll be able to do something. If even if we try it, let's try it. Let us let's say I you know let's see my dashboard data. Let's say I wanted to get something out of it. Let's say I wanted to get this link out of it in the first place. Okay, so what I can see is that this link starts at something called href equal to, right? And then there are some characters, right? So we will have to somehow form some strategy to actually come till here and then get some sequence of characters after it, right? And then, I mean, accordingly, we can do rest of the stuff. Okay. So let's say if this was a normal string, how we would have done it, right? It is just for practice, but dash data is a string, right? So what I could say is that dash data dot find, right? When I will say find, I will find what? href, right? If I could find this particular thing href, then whatever follows it would be what I want, right? So if I just do something like this, if I could just find the value of this, right? It gives me that at 420 position, at this is probably the up till here you already have 419 characters, right? So I think this is the 420th character and this is where it is found. Okay, so what we can say is that if I say dash data and say 420, right, and let me select some random number of characters, right, from 420 to, let's say, I don't know, maybe let's say this is some 15 characters. Okay, so I'll say 15, and then if I see, then I will see that I have this something like href equal to https and g, something, right? So G, from here till here it got, right? But what do we want? We want from here till here, right? So again, I mean, let us proceed and complete this example, but then we will see that why it is very difficult to work with string data. And then if somehow this data which is currently a string could be into a tag form, then we could have done something, right? We could have used a better searching technique, and then that would have been better. So anyway, what happens here is that we have some length, right? So find that this is some uh, thing, and then what we can do is I can say, let's say, um, this I said start index, start, okay, and I would say start link could be at what? This is like 1, 2, 3, 4, 5, and 6 characters, right? So 6 characters after that. So I can just say start plus 6, right? That would be my start link. And what would be end link, right? So end link would be end link would be my start, right? So from my start, uh, I could say that data dash data dot find, right? Find what? Uh, okay, find the mm, from 6. Find let's say uh, this particular thing, right? If I could somehow find this particular thing, then uh, you know I would be able to get it because this is unique kind of thing. Okay, so let me just copy it here and say find this one, right? So this would actually be my end link. What I would then be able to say is that start link and my end link, right? So now I can see that start link is, let me just run it again, right? So now it has given me that particular thing, right? But you could see that it was tedious. We could, uh, had to do some hit and trial and find some special elements based on which you will be able to find. But obviously, you could do that. So, I mean, that is where that is why we require parsing, right? We will see that how easy it would be to get something like this. So let's start that, and let me just put a command called parsing using BeautifulSoup. Yeah, I hope this example was clear to everyone. On a string, it was very difficult for us to extract that data because we only have some limited functionalities, but let's see how BeautifulSoup works. So first thing I will do is I will say from BS4 import BeautifulSoup. Right? BeautifulSoup. Okay, so what it says is that uh, get me, I mean, there is a module called BeautifulSoup. BeautifulSoup 4. It is 4 version, right? And from there you have to get this class called BeautifulSoup. This is the class in which we have to pass something, right? You can pass a string or you can pass something else, a tag or something. Not exactly a tag, but a string-like object, and then that would be converted into a tag for you to traverse. So let's say I have, let me just, I mean, it's already open here. So I'll just use the same file and call it dash file, right? So here I have dash data also. So what I could simply say is that I already have this data in a text format. Whatever data which would be there in text format, what I could do is I could pass it to my BeautifulSoup object. So I could say that BeautifulSoup, and I could pass my markup, right? Here you can see it asks for a markup, and HTML basically means hypertext markup language. So it's like a markup, right? Okay, so let's pass it here and call it dash data, right? It was dash data. So now dash data and one more parameters I will just pass here, LXML, right? It's just a parser, okay? No need to get much into it, but basically there are different kind of parsers. One is html.parse and one is lxml.parse. You would not have to change it, and you will use it directly like this as it shows here. So they are just a parser. Uh, Let me know if this line throws error for anyone. I will just resolve it. But otherwise, if you will use it like this, and there should be no errors. So and then generally we call it soup, right? So whenever we are assigning uh, some text, passing some text to my beautiful soup class, right? It is generally called a soup because I mean you could actually call it anything you want, right? It does not really matter because ultimately it's a variable that you will use further. It's a object which contains it's a variable which contains beautiful soup object. So you could call it Anup also, but that's fine. On the online examples and in the community, right? Coding community, it is used as soup only. So let's use it as soup. I'll just say define my soup or define my uh, beautiful soup object. And then now if I try to see what soup is like, right? It will say that now it is a bs4.beautiful soup object. Okay. Now I can do different kind of things on soup. I think this is the best method to see what all I can do with the soup. So dir soup, and it gives me a bunch of things that I can do. So it can check if it is an XML, right? If it is a markup, if it has some elements, or all of these things which are part of a tree, right? Parents, children, other stuff, right? And then you could replace it with something. You could do dot string to get string out of it. You could get text out of it, right? Lot of things you could do, right? So anyway, let me just try and print one of them. So I can say print soup dot text, right? One of those things was text there, right? So I could just see that whatever text was there, I mean, whatever felt like text to beautiful soup, right? I mean, this one is text, right? So it actually printed that. It will just take out all the text directly, right? And just print it. But obviously, it is very simple, but it might not be useful for you, right? How can this be useful for you? Obviously, if you could do some advanced manipulation on this data, then it could be, but generally it would not be. So I'll just comment it. And until now, I have seen my data, but in a string form. So what if I wanted to inspect it in my regular HTML form? I could say soup dot pretty sorry soup.prettify, right? And what soup.prettify does is that this string data is converted into some beautiful soup object, and that beautiful soup object is not in the form of like this. It could be a gibberish. So what beautiful soup.prettify does is that it just prints it in a more beautiful form. Okay. uh, right, it did not. Okay, here. So I will have to just print it properly, because you see here it has added some dash and dash in elements because it wanted to format it better, but it could not print it. So anyway, now if you print it, we can see that exactly how my file is here. Now my Python recognizes it exactly in this form. And now, since I know that it recognizes it properly, now I can do my operations on it. Okay. So just give me 1 minute, and let's start with some operations. We will use both of these files. So I hope no one has any issues till here, and you are able to properly follow what we are trying to do here. Right? I think basic structure of the HTML pages would be clear to everyone because we discussed them in detail in one of the lectures. So let's start with some traversing, right? I think here when we're doing some But you see, so if I again want to see what all functions were there, I can see that I have I it's not there, but let me just try and print it if it's available. So yeah, it should have been there. It's not showing, but something like .html should have been here as a parameter. I mean, as a attribute to this, but .html is not here. So that is what I wanted to show you. Let me just remove this faltu ka text from here. Right. Let me just delete this one as well as this one. Right. Both of them are deleted. In fact, let me just remove this print and show it in a simple manner. Right, so now I am here, right, and it is now in simple manner. So let me start with something. So let's say I wanted to only get the HTML directly. So I've already seen soup.html, get full HTML page. You could just do soup.html. So full page. And this we have already seen. It would be exactly like this. There would be no difference because all we are saying is that get me all the HTML from this, right? And we can see that now if we see the type of this full page, now we can see that it was actually identified as a tag. So basically what we asked from this guy is that get me everything that is inside in this HTML until here till here, right? Only inside that HTML. So it would be almost the same thing, but then I'm also now asking it that what is it exactly looks like. So now it is a tag, right? It is not a class or something, but it is a tag. It is not a beautiful soup object anymore. It is a beautiful soup element dot tag. Okay. So now since it's a tag, everything is a tag. All of it is a tag. Almost everything that will be read from Beautiful Soup parser will be a tag, right? So we could do some of the stuff on it. Right? Let's say I wanted to just get the let me just try and see that you can get the same tag name here. Not very useful, but let's say you wanted to do some validations and something else you could do it. Anyway, what else you could do was traverse through it. Maybe if I say soup.html.head, uh, what it gives me is that whatever is inside of this head tag from here to here, it gives me all of that. So basically, let's say you wanted to go to this link, right? Okay, so since there is only one head tag, uh, there was no issues, but let's try link. What it will now do is give me a link which is inside the head tag. Okay, right, so I hope this is clear to everyone. So basically how the tree happens from HTML to head to link, this is how you have traversed it. Right? So this is how you can traverse it using uh, simple, I mean using the soup object itself. So if you wanted to do some shortcuts, you could do something like this. So shortcut to to get tags, okay, and then obviously from that tag you could extract the text, right? So you could get the text. Okay, obviously there is no text here, right? From in between these tags there is no text, but you could say title. I think there is some disturbance. Anyway, so here there is no text, but let's say you wanted that title thing, head dot title, right? Title and then set text. Okay, you could get it directly, right? Dashboard template bootstrap. So tags and text, right? This is one of the shortcuts, but generally we would be able to get very simple things only from here, like something like which is directly nested into something. Let's say if it was like here, it is nested at one location, but it was not detected, or otherwise, let's say uh, in UL all of these allies are nested, right? So it can be, I mean, it would not be difficult, but it would not be as intuitive. So let's see how the other ways will work. Okay. But before that, let's just quickly look at this structure. So this is a head, and then these are called tag names. These are called attribute names, right? This is called the value, right? The text inside of the main tags. Okay. And this is a style. Basically, this is some styling, right? And again, these are attributes. Okay, this is a link, right? Link source. Okay, in a tag, a button, something like that. So basically, this is tag, and these are attributes. Okay, attributes can be of different types: class, ID, data target, area controls, and blah blah blah. A lot of types, data feather, different type of attributes. So why would we would ever need to get them is because they are the identifiers of our actual data, right? If you could somehow find that the data feather is file, give me that tag, right? So if I could find, I would find this tag, right? Not this one. Let's say I wanted, I would find that class is equal to nav link, right? I would get this tag, and from that tag I can say dot text, so I will get my data, right? So make sense to everyone. Let us now do some of the stuff. Okay. So before that, let's say I wanted to let us start with very simple operations first. Okay. Let's say I wanted to get all the links which are available on this web page. So this is my web page look like. Okay. I have a problem that I somehow want to get these links, right, which is displayed, uh, you know, here whenever it is showed, it is displayed here, right, and at the down. So I want to get all of those links. Looks like all of them are same, but I mean, for our exercise should not matter, right? And obviously there can be other links in that, right? Here we have a link, here we have a link, okay? Some other links maybe, right? So our task is first to get those links irrespective of where they are placed, right? So what I can do is that I can say something like this soup.a, right? And what it would give me is obviously the first element that it finds. Right? Here also it happened like that. The first element it finds, it gives. But I want all of the links, right? So what I can say is I can, in fact, before even going at that, let us see what that soup object actually has, right? Once more, I think we've already seen, but here we will just see that it has a bunch of options for us, right? And one of those options here is called find all, right? Or find next, or find all, right? All of these things are there, okay? So let us try one of those, right? And say, I mean, we will only use only those which are useful to us. I mean, there are so many that we can use, but whichever ones we like. So you have two methods for each of those functions. Anyway, I could say find all like this and say a, right? And it will, what it will do is that it will find all the a elements and give it to me as an iterable, right, within a list. So this is a list containing all the tags separated by a comma, right? You can see easily that this one is tag, right, separated by a comma. This one is a tag, okay, and this one is a tag, okay. So what it did was it found all the a links, right, anchor links, basically the actual links, and then returned it into a list, right. What you could also do was find all, right, and it would, the result would not change, right? It would be same. And we already saw when we were doing dir soup that we have two methods, find all as well as find all. So you could use any of it, right? It just gives you flexibility. So, but that's not all, right? I mean, I have a list, but what I want to get only the text, right? I don't want to get anything else. So I can call this, let's say, uh, all links, right? All links, and I can say soup.find all. Let me just define this as find all the links in the web page, right? The web page. So I can do this, and then all links with from all links. It is an iterable, right? So I could iterate over it. So I will say for link in all links, for link in all links, right? And what can I do with the link, right? Each link now is a tag, right? So I mean, basically, if I use it as a tag, let's say for tag in all links, right? So all links is a list, and every element of that link is a tag. So I could do something with that tag, and we've already seen what I could do with a tag. I could get text out of it, right? Okay. So if I could just print the text uh, of all of these links, right, I could just see that what all of my links are. Again, I'm sorry, I asked for text. I did not ask for links, but we'll see that. We'll ask for links also. But we can see that whatever those links were, we got all of those, whatever, the text associated with those tags. Let me just print tag once again, just to see what I actually want, right? So what I want is uh, the href. So uh, what I could probably do is say something like that. Okay. And then what it would do is print all the links which were there, right? So I think all of them contain this particular link only, but uh, you know, let's try and take something else, because these links have a class, right? So probably we can extract that, and that would make more sense for us. So we'll just say class, right? And now we can see that all of them, had some classes which are printed, right? And it is printed as a list because classes, you can have multiple classes associated with one tag. So that is why it again returned a list, right? So each of those is again a list. Okay. But anyway, let's say I wanted to get all the texts, right? I'll just all the classes of links in the web page. Let's say I wanted to get text of all links in the web page. Okay. I would do the similar thing for tag in all links, right? Makes sense. And just say print tag of tag.text. That would give me the text. But I don't want to print it. I want to get into a list. So I can say text list, let's say, and I will let me define it empty list. And then here I can just say that text list, right? Dot append. I think we have seen all of these methods. So now if I at last, after my text list is appended, I can just say text print it. Let me just do this thing with here as well. Classes and this. and then just say classes.append. Classes.append. This should make sense to everyone. I'll just print my text list. So what it will do is just give me a list of text. Okay. It has some dash and dash in, so I could just replace it maybe. Replace, I could do it right. Replace slash n with the replacement, which is this, right? Empty string. Now I can see that, that those slash n's are gone. All right. Anyway, so this is how you can see that it was useful. But I would just like to show you one thing using list comprehension. I just use list comprehension. What you could do is that you could uh, take all of these lines and just do something like this. Say class list, something like this, class list, and do a list comprehension over it. First, what you want to list comprehend over, soup.find all, right? Soup.find all, and find what a. This will be an iterable, right? So I can iterate over it and say for x in soup all. For x in soup all, what do I want? I want x ka href, right? This one I want, or x ka class. Right? I hope this one is again understood by everyone. So now if I do this whole of these things is again here in one single line. So I can just do that and those same things will be printed here. Okay, so this is how you can use list comprehensions along with your own things. So just a 1 minute break here. Okay, so I think yeah. Now let's take another example. Let's say I already found all the links in my web page and saw that it was of no use. So let's say I want to find all the links in my this one, and since links has some href, maybe that I can extract. So let me just try it with you and say just paste this thing here and find all the href of link tag, right? Link tag. So what is the difference between a and link is that the a tag is generally the links that you see on any page, right? So I mean this is kind of a link. If I just inspect it, I will see that it was actually inside a tag, right? Okay. So whatever links that you see on the screen, right, which you can view are generally a tags, anchor tags, and whichever ones you cannot see, right, the links which are used to link some other objects on the web, some other resources on the web, right, which you cannot see, right, like you paid source. If you do, you can see that there are other links here. Okay, link something something something. These links you cannot see, right? So these are the other links. So let's say I wanted to check on a web page what all technologies they are using, right? So there is a site called uh, built with. Okay, built with, right? What it basically does is that if you give it some site, let's say Google or Gmail or any site, it basically gives you all the technology that it is using, right? So let's say I say Airbnb, right? Airbnb.com. Okay. What it will do is that it will give me all the technologies, like whichever it would be able to, give, uh, it will be able to find, it will give me all of those technologies that it uses, right? So Airbnb in terms of technology uses all of these. So it uses so much, right? It uses Maps API, it uses Facebook CDN, it uses Apollo. Basically, Apollo is database, right? So PHP it uses, Perl it uses, so much it uses, right? Anyway, so built with what it would built with would have done is check those link tags and saw that where they were actually linked to and just displayed it on our website. It uses React, jQuery, all of those stuff. Just listed on its website. So you can see that again, this website is using a web scraping technology to create their own website. Right? But anyway, let's do our own thing. We want to get the link, right? And we want to get the uh, class. There is no class associated with the link. Maybe we can get rel, right? Rel is generally associated. Here we can say rel and in a link, right? But ultimately we want to get the href, right? So I could maybe mm, maybe say here that not text but the direct href, right? Href. Now this one should give me the rest and this one should give me the link. Okay. So I have two lists now and one of them gives me the link and other one gives me the rel, right? Rel thing. So first one is canonical, Apple Touch, icon, manifest, etc. Right? So you could now see that how easy again it is for you to get this data. Yeah, this is also kind of a data, right? I mean, you have just shown you that this data, either I mean, no one would have thought of usage of it, but someone thought and then they created a technology to check what technologies are being used on a particular site. So I think this is a good example. But let's say I wanted to do something specific, right? Now here I have a rel icon, right? So let's say I only wanted the one which has only this rel as icon, right? So this is something unique. Okay. So let's see how I could do that. Again, it could be very similar to this, maybe almost similar, but one more thing. I can say, let's say my problem statement is get link link tag with rel as icon. So I only want the link of the icon. Icon is basically whatever icon that you can see here, right? In all of that, that is called icon. So anyway, let me just write code for it. What I can say is that rel icon, let's say, and rel icon I can do what soup dot find all, right? Soup dot find all, and right. Here what happens when I do this? Here you can see that it asks for a name, right? Name I will give, right? Name is just a tag name. So A, T, D, table, whatever you want. You already know about them. And then there is something called attributes, right? So we have not seen this yet. What attributes means is that basically you are allowed to search using these attributes, right? You could specify an attribute and whatever that attribute that you specify, only if that matches this particular tag, this will be selected or it will be rejected. So let's see quickly how it works. What I want is a link tag, right? And then I have something called attributes. So 80 years, right? So I can specify it or I can just not specify it because it's a second anyway positional argument. I can just say that rel equal to and icons, right? That's it. So it was asking me of dictionary of attributes where a key and a value is required. So my key would be rel, right? I want rel and the value would be icon. I want a link of rel icon, right? And that would be my rel icon. And if I print that rel icon, I would get all the tags associated with because this would give me tags. So I have all the tags which has rel as icon, but only them which has icon. I could now print the text of each of them. So I could say that lambda or equal to lambda x, right? And I would just print what x dot x dot x x, right? Because I want x out of it, right? So I could do something like that. I hope this lambda function by now is clear to everyone how it works. Uh, just some syntax review. Now this is fine. Right? So this is exactly what I want. I just want to print everything in that iterable. Okay. So what I could do was then pass something, right? So in fact, I can just do a map and just pass it a rel icon, right? So each of element of that rel icon should be again it's a map. So let me just print a list. I want a list. So now it would be able to give me something, right? It would be able to give me that. So I hope this is now clear to everyone that if you wanted to get it from attribute, uh, obviously not a great example. So let's take some great examples. Right? Let us take this great example, which says that you have to take only those A anchor tags, right, which has a nav link on top. So basically, what I want is that I want to get this one, right? Not these ones, maybe orders, products, customers. Where is it? Yeah, this one, these ones. So these are navigation tabs. So I want the names of these, right? So I mean, I want basically these data. So whatever names are appearing there, I want them in a list, right? Because ultimately we have seen till now that ultimately everything we want in a list, because that list you can pass through numpy arrays, you can create data frames out of it, and then main manipulation is just very easy. So let us get this. So what I can say is that again I can say nav nav is nav simple or nav list. Just make more sense. Nav list. And then I can say to dot find again, right? Find all because there are multiple. I can obviously do a simple find and it would find a returns only the first child of tag matching in the given criteria. Right, so it could find only one, but I want to find all. So I will say find all, and my I want to find all A and on some attributes, right? So those attributes are class, right? And that class is nav name. Nav. Let me just try and print it to see what it looks like. Nav link, nav link. I can see that again it's a list with some items, right? This, right? All of these are now. So I can see that all I have to now do is get the text out of it because obviously there is one more tag here called stand, but that stand does not really have anything. So if I get the text of this poll, I would ultimately get this. So no need to worry for this stand. I can just get the text, right? So again, something similar I could do or just use a list comprehension where I would say that print what the list where I want to get the text, right? From what? Sorry, for X in navlink, right? Easy. Navlink. And I now will have a list printed which has only those navlinks, right? Obviously, we could replace the slash ends with nothing, and then it could do the printing. So we got sign out dashboard, current orders, whatever was there. Sign out is I think on this side. Sign out whatever current month last quarter. So I think fairly understandable. try something else. Uh, let's let's go on. Let's try. We can get this table. So ultimately, generally, we will find some tables in our data, and we would want to extract that table data into a spreadsheet. So let's try and extract this table data. So what we could do, how would our strategy be, right? We would first wa- uh, want to find this table, right? We could first find this one, and then inside this, we could find this, and inside that, we could find this. But since I can see that there is only one table, there is no need to go from tree to elements, right? I can directly go to this element, right? And then in that element, obviously, I will have to go to this tr and then th, right? Traversing will have to be from parents to children. But so let me just try and demonstrate that what I'm trying to say. What I'm trying to say is that if you get a table of class responses, and I would just say that should dot find all and say a div. Just a second. I will just say div and will say class of. Okay, so now this is my division. If I would just uh, show you what it looks like, so just quickly print it. It would have that table. Right? So basically, it has that table, and it has only one element with that thing, right? So I mean, for me uh, it is still useful, but not that. Let me show you what I'm saying in terms of table. So if I said table and then set this one, I copy it and paste it here. I would, you know, get that table directly. Right? I would not have to go through that div. But let me go back to my example where my div is there. Let's say I have this and I assign it to something. Right? I say table div. Right? It's a table div. Table div is equal to this. And now my table div contains a list with a tag, right? That was a div tag, right? So, I mean, what I could do now, let me just print it once and so that there is no confusion to anyone, including me. Right? So it ran and now it gave me a div. Okay, I will just div. And now what this div is now is a tag, right? In this div, I could just say the zeroth element, and that zeroth element will be simply a tag, right? So it was a list, but now it's a simple tag. Okay. How I knew that it's a tag is by checking the type. What happened is just checking the type, and it would tell me that each of the element in that list is actually a print is actually taking time. Yeah, is a tag, right? So basically that list contains tags, and we already saw that my HTML, this one, was also a tag. So basically I can do again some stuff, find something in my tag, right? So what I could do was that table underscore div, zeroth element is a tag, and then I could again invoke find all on it, right? And in that I could find my table, right? Now if I do the same thing, right, what happens is that I again get my table. Okay. So each of the tag elements themselves have all of those properties of a beautiful soup element, right? All you need to do is qualify for a tag. So basically from the division, you could then again find table, right? But that is what I'm saying, that you don't need to do that here, because if there were more division tags with same class, then we could have, have some issues. But anyway, here it's fairly straightforward, so let's use it directly. I hope this is clear to everyone what we say. Let me just let it remain like that and say table list, right? And table list. And from this table list, I can just get the table tag. That is the first one. So I'll just say table 0. Okay. So my table tag is now with me. Now in this table tag, what I could do, again, I will have to do something like this, because my only from tag I can find the elements. If I did table tag dot text, what would happen is that I would get all those texts, but I would not get it in a format I would want, right? I would not get it in a list of list format, or list of list. I can pass it to something and then it can be exported to Excel, CSV, whatever you like, or it can be directly exported to a CSV. So my ultimate aim is to get into something like that format. But I think when I will do dot text, I will not get. So I will have to do the same things. I will just say table tag, right? So first I have some 4 headers. Just see 5 headers, right? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So to get to these headers, first I need the th ones, and that's it, right? In th ones I have one tr, and in those tr we have ths. In those ths I have header. So if I wanted to write in one line, now again I have only one t head, so it gets simple for me, right? I can do something like that, dot t head, right? And then I could do find all, right? Find all, what find all? Tr. Again, it's only one tr, so I could do something like this and then say find all, right? Find all what? Now th, right? Th does not have any attributes, so I can directly get it. And let me try and print that and see what we have got. Okay. So what we have got is a list with those headers. Somehow if you can directly get the text, right, it would have been very easy, but we'll have to probably, iterate over this. So this is a list. Again, I will do my list, normal list comprehension to quickly get those elements. I will say headers, right? And I will say headers equal to this one, x for x in table dot. In fact, I want x dot text, right? So now if my headers will be that. Okay, so if I print my headers, I will get my headers. And then all I need to get is my values. And if somehow I could uh, create a list of lists out of these two data frames, I mean, these two different kind of variables, right, headers and values, then I could export it into a CSV. So I'll just write it here. I'll just say that extract the headers, and I will create one more variable to hold that list of lists. So I have a list, right? This should be into another list, right? So I'll just say my final data, okay, final data, right, equal to this empty list, and then I could just append it, right? I could just append my final data dot append this list, right, headers. So until now I have headers. Easy. Now what happened? Now what do I want? I want these values, right? Again, if I inspect my page, I can see that there is literally nothing associated with it. So I can, if I could directly get the T body and then TR and find the TD out of it and then get the values, it should be fairly straightforward for me. Okay. So let's say I come here and do exactly that. I say extract the values. Right? So I extracted the headers by traversing the th tags. Right? I will extract the values by traversing the TD tags, right? Okay. So my values, right, should be again very similar. I will start with my table tag, right? In my table tag, there is something called T body, right? And since it is only one, I could directly say dot T body. I did not have to do dot find all and then in that T body I could directly say, and then tier, and then in that I could find th, right, td, but it would give me only the first element. So I would say find all, right? Find all what? Find all my tiers, right? They have tiers. Sorry, I've already found tier. They have tds, right? And this is my list of all the tds. But let's say I wanted to get only text out of tds, right? What I would do is again a very simple thing, right? I will say value is equal to a comprehension, right? In that comprehension, I want to get a text for all the rows. So for TD in TDS, right? TDS, yeah. This one is my TDS. TDS. So this is it, I hope. So now what happens is that, uh, so what happens right now here is that this does not work. Let me try and print it and we'll see why it does not work. So values, x is not defined. So x is I'm sorry, for x in this one. Even then it would not work. Let us try again. Uh, so what happened was it worked, right? But it did not work the way we want. It only basically got the first one, right? And then it stopped. It did not do anything else because what it did was it found something and uh, basically in this TRs we did not have one, right? I mean don't have only one TR. So we have in T body we have one TR here, one TR here, one TR here. So it did not work, right? Only with the first TR it took and found all the TDs, found all the TDs in first ones and just got the values of each of it and printed it, right? But what should be our strategy? So this would be extracted TD tags for first row, right? First tier, and let's just get it for all, right? For all tiers, all table rows. So what we could say, we may not be able to use a list comprehension here because now first we have to traverse over all the tiers. Okay. So what I can say is that just get it here. This again is my what say is a tag, right? Uh, and then I would do find all here and say tier because there are multiple ones. Again, that is a what? That is a table row. So in that table row, I can again find my TDs, right? So for X, I could find all my TDs, right? TD. So, but again, I mean, these are TDs, right? So I actually want text from it. So I can say for Y in X dot find all, what I want Y dot text. So this is my final list which I want. Okay. Now if I print this one and just, I hope this is clear to everyone what we did here. Let me just print it. Again, X is not defined because where is X? Where it is? X is not defined. For X in table dot here, okay, and for Y in okay, it looks I mean, it looks okay to me. Let me just check this. Mm, Let me just rewrite it. Maybe there is some issue there. I will just say for what do I want? I want to get all the TVs, right? So if I y.text for Acha, this one is not actually found here. This particular X is not being found, right? So table tag dot tbody dot find dot here. So if I just print it once and see what it has, this is how we actually debug our code if we have any issues. So it gave me a it gave me what? It gave me a list with all the TRs, which is fine. I mean, which is an iterable, and that is exactly what we want. Okay, uh, right. Let me not say find all, but let's first see X only so that we can easily debug this, right? Let me just print the values and see what it should be a tag, right? So basically, each of them will just output you some tags, right? This is one tier and this is another tier, right? Basically, in all of these tiers, you should be able to find TDs and then get the text out of it, right? So that is what we were doing basically. Uh, okay, so maybe let's say find all and let's say TD. Let's see how it works like, and then we can proceed to the next step. So basically, it gave me all the TDs, right? Each in lists of list form. Okay. So what I could again do is maybe traverse over this list and again say values equal to y for y in values, right? So what I want, right? I want text for each of them, so I can say text, right? So uh, again, these are lists of lists. So for y in values, right? For x in tags, for x in values, for y in td, y dot text. Uh, Doing this looks like there is some issue here. Again, let's I'll just search here. Nested. If I have something like this, I can always search. You will have to search something like this. Nested for loop in list comprehension. Right? That's what we are trying to do. So when I will search something like this, I may get some of the examples, right? So it says you could do something like this. Right? So you will use both of those variables. So for J in S1 and for K in S2, basically, if you have something like this and you're doing something like this, what you would do is something like this. But let me show you more intuitively, then it would be clear. Let me just comment this line and comment this line as well. We will come to these two examples, but let's say you had only these ones. Okay. Uh, let's do it step by step. First, extract these ones. I will just say all table rows. A normal user, normally you would do something like this. You will say all rows, right? All rows equal to this, and then from all rows for row in all rows, what you could do is that now each row will be what? A tag, right? You could find something from it and you could say find all, and then since you wanted to find TD, you could find it. you could say that TD equal to something, right? And then let's say you are holding one uh, TD, right? And now since that is TD, right, those will be TDS. Uh, Please tell me if this is understood to everyone. What I'm trying to do is that I have taken out all the TRs from what? T body. So I have come till here, T body, and then I want to get all those TRs. I have got all those TRs. In each of those TRs, right? What I'm doing is trying to find those TDs, right? These ones. Okay, that's exactly what I'm trying to do. TD, and then those are again a list, right? This will give me a list, as this gave me a list, right? So I could traverse over it. I could say for TD in TDS, what you would say is that, let's say you had defined a list here, right? Or a list here. It said, in fact, you have already defined it here to hold all the values. So what you would say that my PD list equal to this, and then you could just PD list dot append TD. So what would happen is that at this particular point, every time my TD list will have something, and then what you would do is that just final data dot append my TD list. So what happened here, right? If I just print my final list, final data, okay, you would see that I have all of those in list of this format. Here again, some problem that I was just appending the list. It should be text, right? So now I can see that I have those headers as well as those columns, right? So what exactly happened here was that you got a TD, right? That was again a list. You traversed over it. You took each of those elements, took a text, and you defined a temporary list to hold that value. Why? Because you wanted a list that you could append into the final data, right? Here you appended a header list. Now after that you had to append each of the values list, right? So each of the value list was TD list only, right? So you finally appended it and then you printed it. Okay. So I hope now, I mean, again, this is simple. If I said import pandas from PD, right, and then I said data df equal to pd dot data frame and just pass this final data to it, right? What I would have is a df pandas, sorry, import pandas as pd, right? We use as PD. So what would happen is it would be read, and then now if I just do df dot head, right, the same functions that we did yesterday, I would see that it is now read into a proper data frame. And then again, if you wanted, you could just do to CSV and say exported dot CSV, right? CSV, and then if you ran it, what happened that if you just refresh it, you would just get this exported dot CSV. If I download and see it, what I would have is this one, and this now has the data that I want. So basically, I wanted to get this data till 1015, right? I have got till 1015. This is my data, and these are indices, right? Obviously, I could just ask it to not print it, right? I could say exported.csv, and then if I see it here, I can see that I can, give all type of things here. I can submit specify index labels and column labels as well. Anyway, no need to explore that, but we can see that ultimately this is what we do for any kind of web page, right? Okay. So I think that is it. This should make you understand how parsing works. If I just quickly had to do the same things using my pricing, right? And what I would like you to do is, you know, uh, create uh, create a create a dictionary, right, with the values as the price and sorry, with the key as the price and values as these numbers, right? So my next exercise is uh, my next exercise is exercise. So I'll just take a pause. Anyone has any doubts till now? Is it whatever is being explained? Is it clear to everyone? I'll just take a formal go ahead from everyone. Ranjay sir, Vignesh, Dev, any issues with whatever is being shown till here? No. Shallow. Great. I hope this is simple and clear to everyone. So I'll just proceed. Thank you, Vignesh. My exercise is to form a dictionary, create a dictionary, right? Dictionary. Dictionary is again a JSON-like object. So create a dictionary with what? Dictionary with price as keys and description as list of values, right? List of values. Okay. So basically, my output should look like something like this, and so I'll just say, let's say $0, or let's say this was $20. Okay, $20. I would say this, and then whatever my this is great, and then you know two of them, right? Something like this. So this is the kind of structure I want. So let's see, let's do it. So again, I can do something like with open, right? With open what? My pricing.html, and open it in read format as price file, right? Price file, and then I could say price data, and then I could just do what? Beautiful soup. My file is already there, so I would just say beautiful soup uh, price file, right? And then again that parser XML. Okay, this should be more intuitive as I can directly call it soup. Okay. Now, if I just wanted to check, I would just say print soup dot pretty pie. All right, and then I will just print it and say that again. Now my soup is printed. So this is fine. And now let's proceed to what we want to do, and we can very quickly do it because we have seen so many shortcut ways of doing it. So let's get to here. Only thing is that we will have to convert it to a type that is being asked. So let's see how I could do it. First thing is that I want this particular text, right? One of them is in small kind of this thing, and one of them is in under this tag thing. But doesn't really matter if I just get this one, right? If I just ask it for the text, it should combine these two, right, and give it to me. Okay. Apart from that, what I want is in this UL tag, there are some lists, and it is there, right? It is there. So there are some three tabs, and all of the S3. I want to get that those things and convert it into a data format that I want. So what I could do, I mean, this is very simple. We would have very complex data, formats which are again written by people, right? This is again written by someone, okay? This is some code written by a web developer. So would be written by someone, and then that, it just depends on the style of the developer, how they have written. Accordingly, you have to traverse the tree. So anyway, I first thing is that I have this H1 where all of those H1 has a particular class. So it is very easy for me to get that, and then let me get it easily. I can just say titles, right? Titles titles equal to my what? Just let me check once. My class with this. So I can just say soup dot find all what? H1, right? And using a class, right? I can say class, and then that class would be my copy class, this one. And now I should have all the titles in this. But then that would be an iterable, right? So let's say I directly want to I mean I want to finally get the text out of it, right? So let me do a list comprehension right here and say x dot text and say for x in, right? Because all of them will be ultimately some tags, right? So my titles, if I just print my titles once, right, and my titles would be okay, fairly simple. So now, but I want these as my dictionary keys, okay? So before creating any kind of dictionary, I would need values. So let me also get these values. So how I can get values is that first I will have to get the ULs of this particular class, and inside those ULs I will have to find those LIs, and in each of those LIs my text lies. So it should be fairly simple. It's not getting copy. And so my descriptions, right? And my descriptions is basically soup dot find all again, and find all what? UL, right? UL with some class, okay, some class, and that class is this one. So my descriptions will have ULs, but again this is an iterable containing lists. So you know, I don't want it like that. I want all the tags. Okay, so let me do it the normal way, and I will say let me call it ULs for now. ULs. So I will say for LI in ULs, right? ULs for UL in ULs, okay? For UL in ULs, right? You could name it anything, but I just named it UL because I'm just traversing in all the ULs. So I'll just do ULs in ULs, and what I need in that UL, I want to find the LI. So I will just say that uh, uh, LI in UL dot find all, right? Find all, and find all what? LI. This will be some LIs, and from on that LI I can traverse and just maybe define something here called LI list, right? And empty list, and then here I can just LI list dot append, right? LI dot text. Okay. So I hope this makes sense. LI here, LI dot text. I append it in this list, right? So, but again, I need to. I mean, in the next iteration, it would again go away, right? So I need some further bigger list to hold that, right? So I'll just say value list, right? And call it an empty list. And here, after each of those loops, I will just update it value list dot append, right? Li list. Okay. So now my value list, let me print both of them. I printed my titles, and my value list should be something, a list of lists, right? List of lists. Right. So now it is easy for me. I have three lists of lists, okay, and three keys. It should be very simple for me. What I could say is that let me define a empty dictionary, right? Final dict. Okay, final dict, and that is defined as an empty dictionary, right? Then I can say that for J in titles, right? For in fact title in titles, right? Makes it more simpler. And then I could say that final underscore dict, and then what? Here I can define the key, right? I could just say title, right? And then put it equal to the value. Value is nothing but, you know, uh, mm, um, values will be this one. Okay. So what you could say is, mm, I mean, you will have to find the same index which where this one exists, right? So if you're taking first from here, you will have to take first from here. If you're taking second from here, you will have to take second from here, right? So how you could do that? You could say that uh, titles titles dot index, right? Index of what? The title itself. This will give you the only index, but this you have to take from the value list, okay, right? So from value list, you will take this index, okay? And then if I now print my final date, let's see if it, yeah, it gives exactly what I wanted. Okay, with a dictionary with price as keys and description as list of values. Okay, this is what we want. So I hope this one is clear to you. What we are actually doing is that from the value list, we want to get that particular index corresponding to the index which is here. So I am taking the index of title in titles, right? My current element का index क्या है? And then I am just passing that index to my value list because it would be same, right? So this is another intuitive way to get my do something, right? Just one or two more examples we will see, and then this should be it for us. Okay. Let's say, okay. Anyway, I think this should be enough. What we will do is try requesting some other page, right? Because this should be enough. Uh, Let us try, I don't know, this one. Or let's take some data. Data is available on many sites, but which one should we do? This is one of the sites from where you can fetch data generally for data analysis and stuff, but you can practice getting data from here as well. Right, so um, the site has changed a lot. Premium has sample data, but don't want that. Or that's the thing is that I wanted to, because I had mentioned that we would do Vidyut Prabha here, but Vidyut Prabha is generally very slow. So that is why I didn't want to do that. But anyway, let us do that. So let's say this is my page and view page source. Okay. And so there is something here, right? Some links. So if I have, you can see that there is something called href, and it basically gives you the link of where that data is available. So we will try to get this, right? But we will do a full-fledged way of web scraping. So get all the states data link from Vidut Prava. Okay, Vidut Prava. So that should be fairly simple. First we will do is we will import our request module, right? And from request we can say request dot get, and get what this. So this is my this is my request, right? This should get me a response, okay? And right. So if I just try to print my response, since BeautifulSoup is already there, so I can just, before printing it, pass it to my BeautifulSoup object, right, and say response, right. So response is not I mean, it's an object which has other things. So there's something called text, right, one attribute. We'll pass it here and say LXML, right? And then let's try to print the soup one, and soup dot prettify. Prettify just prettifies it to the way it was earlier available. So it will take some time because that website itself is slow. Hmm. Waiting, waiting. One of the reasons I did not want to do this right now, because we have ourselves built scrapers for this particular site where we get this demand data for all of the states and other data, which is then again used in one of the dashboards that we have created for PXL for our team. But okay, finally it gave me the response, and the response basically, if I just kind of want to check it, right, I can see that it ends at this kind of get shortage detail thing, right? And get shortage detail is my last function here anyway. So I can fairly assume that I have got all the data that was available on the website. So this is my starting point to understand and inspect what I want. Okay. So anyway, what I want, how to inspect it, I want to get all the links of these sites. I will do right click, inspect, right? When I do inspect, I will just bring it here. In the inspect, I see some random stuff. Okay, I don't know what it exactly signifies, right? So this is a SVG page. So this is some SVG code. Anyway, no need to get too much into it. What we want is our links. So we will find where our links exist, right? So I mean, obviously not on these. Here are our links, right? Here is my link. If I inspect it, I can see it's a with some state name in front tool type inline, right? If I inspect one or other mode, right? Let's say Haryana, the class is same. So it becomes very easy for me. Now I have a same class. All I have to do is find A with some class and then get the text. In fact, I don't. In fact, let's say I want to create a dictionary where I want to have the value as key and href as the actual value. So let's do that. Let me define my problem. And I will say get all the states link from data Wikipedia and save it in a dictionary of key value pairs. Okay, that's my problem. So from here until here I have got it. Now I can just get all links, right? All links equal to soup dot find all what anchor tag with some class, right? With some class. My class, I will just copy it from there, right? So my class is this one. So here, okay, find my class, and then what I will get is an iterable, right? I could get values directly using my good old this comprehension, right? X dot text for xn, right? Soup.find. So good old way. All links I have, all link text. Those are only text. What I want is hrefs as well. So I'll say all link hrefs, right? Uh, h, and say again something like that only. I will say soup dot find all, right? Find all what an a, but you know in that a I want to get this class only, right? This one, the same ones, but from there, what I want, just okay, yeah. So what I want is only the X. So I can just again use my good old uh, comprehension. I will just say X and href from what? From for X and this. Again easy. So I could do it both of them in one line, and then I want to publish it as a dictionary. So what I would say is that for J again text in all link text. Similarly, all link text, and I can do what I can do. I can before that I can create a dictionary, right? My result and my result it could be this empty one, and my result dict now. Okay, now should hold values from the text ones, right? And get me the href ones, right? So, but again, for href ones, I will have to uh, give them the same index as the text ones because, I mean, the number of text as well as the number of hrefs will be same, right? So, what I will do is something like that only. I can just say all link text dot what index, right? Index of what text. So I will get the position of this, and then I can pass it to my what all link dictionary. So that will give me my link, right? And then I could just print my result deck, right? Result deck. So what I would get is again we might have to wait because of Vidut Pravashan. Next, if this does not run properly and gives an error, I'll just copy it and run it in another one of the cells. But before that, let us keep it like that. Just wait until the result comes. So I think here you could see in like very lesser number of lines. In fact, let me just replace some of the things. Replace that can by simple. And I will just copy this and get into a new one, right? So what I could do, I also want to replace those R's, right? Dot again replace those R's slash R, right? Slash R2 also. So I was able to do some stuff in very few lines of code. So I'll just print it again. And even though I've got my what I want, right? Each of the states are associated with something, all of these. So this is exactly what I wanted, and my objective was complete. But we could see how easy it goes for us to do it. So I think that is it for today's session, everyone. Today we have done some fair amount of web parsing, web data parsing, and ultimately we could see that as we pass some string, ultimately what we have to do somehow get the response on the site. and just get the text value out of it and pass it to BeautifulSoup. Rest everything is done using BeautifulSoup. Okay. And then later on you could use pandas to export it or normal CSV, whatever you would like. Okay, up to you. So, but I think that is it for today's session. And from today's session, the takeaway should be that you are able to extract most of the websites that are present on the web, right? Using Beautiful, you should be able to parse it. Okay. So, anyone, any doubts? Please let me know. I'm here, right? Please give me a confirmation. Dave, Dhananjay sir, and Vignesh. If there are any doubts for today's session, please let me know, or we can conclude today's session. No doubts. Right. So that is great. I will just stop recording the session